Hi, my name is Renee Rizzo. This will be a teacher-facing video which will guide you through my adaptation of Physics Unit 5, Day 11 in the New York City Department of Education Teach Hub for students in alternate assessment settings. In this video, I will be using Nearpod and demonstrating various features it offers to make lessons more accessible and engaging. I will also show you 3 differentiated levels of assessment for this lesson, which I created using Google Forms. Before I begin, I just wanted to make sure that I am sharing my sound with you throughout this presentation. Yes. Okay. So here is the Nearpod. Physics sound waves. From the original lesson, focus question, how do sound waves get to our ears? Objectives, describe how to produce a standing wave. Create wave interference to influence certain outcomes. The next generation standard, I believe, is addressed. RST3. Analyze how and why scientific ideas and reasoning are developed and modified over the course of a text, source, argument, etc. Analyze, evaluate the results and conclusions based on explanations in the text. The NICE DLM essential element addressed. Determine how individuals' ideas or events change over the course of a text. An old riddle. I incorporated this as is from the original lesson. Crack, crash, thud. That's what you'd hear if you were in the forest when this old tree cracked and came crashing down to the ground. But what if there was nobody there to hear the tree fall? Would it still make these sounds? This is an old riddle. To answer the riddle correctly, you need to know the scientific definition of sound. Sound definitions. In the original lesson, this was written in paragraph form, but I broke it down into separate definitions so that students could see it more clearly. Scientific, the transfer of energy from a vibrating object in waves that travel through matter. Everyday, most people commonly use the term sound to mean what they hear when sound waves enter their ears. Quoted directly from the original lesson, the tree generated sound waves when it fell to the ground. So it made a sound according to the scientific definition. But the sound wasn't detected by a person's ears if there was nobody in the forest. So the answer to the riddle is both yes and no. Open-ended question, which I incorporated just to check for understanding. What is the scientific definition of sound and how is it different from the everyday definition of sound? I would definitely answer this in a class discussion with your students. How sound is heard, again taken directly from the original lesson. A guitar string vibrates back and forth. Vibrating air particles pass the energy of the vibrations away from the string in waves. The sound is heard when the sound waves enter a person's ears. I included a video about sound that I found on YouTube that I thought breaks down the topic for a student that is more at a level that is more accessible for students in alternate assessment settings. I'll show you a short clip of the video.
We call sounds by a lot of different names. Like if a sound is really loud and kind of unpleasant, like when there's a lot of traffic going by, we sometimes call it noise. And if a sound is made by an instrument like a piano or a ukulele, we call it a note. And we call lots of notes together music. And some words are kind of like the sounds themselves. Like when fireworks go boom, popcorn pops, and bells go ding-a-ling. It doesn't matter what makes a sound though. All sounds are made the same way, through vibrations. When something vibrates, it moves back and forth really fast. So fast, in fact, that our eyes often can't see it moving. But other parts of our body can sense vibrations, and I bet you know what parts those are. That's right, our ears.
So the video explains different types of sounds, that all sound comes from vibrations, that when we make a sound, a vibration shakes up the air particles around it. We call the path of vibration a wave. When sounds reach our ears, they make our eardrums vibrate, sending a message to our our brains, excuse me. Students are encouraged to experiment with different types of sound using a rubber band around a can. They're asked to pull gently, pull harder, and compare the sounds made. They are also asked to stop the vibrations to prove that the sound stops when vibrations stop. I would definitely recommend incorporating this hands-on part of the lesson with your students, especially for your tactile and kinesthetic learners. This would really make the lesson come to life for them. And this was a question that was incorporated in the original lesson that I just made into a collaboration board so students can see what other students in their class think about this topic. How do you think earplugs work? Taken straight from the original sound Q&A, if there were no air particles to carry the vibrations away from the guitar string, how would sound reach the ear? Answer, it wouldn't unless the vibrations were carried by another medium. Sound waves are mechanical waves, so they can travel only through matter and not through empty space. Sound waves and matter, also from the original. Most of the sounds we hear reach our ears through the air, but sounds can also travel through liquids and solids. If you swim underwater or even submerge your ears in bath water, any sounds you hear have traveled to your ears through the water. Some solids, including glass and metals, are very good at transmitting sounds. Foam, rubber, and heavy fabrics, on the other hand, tend to muffle sounds. They absorb rather than pass on the sound energy. And finally, also from the original, how can you tell that sounds travel through solids? One way is that you can hear loud outdoor sounds such as sirens through closed windows and doors. You can also hear sounds through the inside walls of a house. For example, if you put your ear against a wall, you may be able to eavesdrop on a conversation in the next room. Not that you would, of course. So, although I incorporated a lot from the original lesson, there were things that I did leave out. The original lesson goes a great deal into frequency and amplitude of sound waves, which I thought would be too complicated for my particular students. But if you think that would be something that your students are capable of doing, then I would definitely recommend that you take a look at the original lesson. So now I will show you my 3 differentiated levels of assessment that I created in Google Forms. This is level 1. What part of your body do sound waves enter? A, your mouth, B, your ears, C, your eyes. As you can see, I use picture supports for my multiple choice options, and I got these from unsplash.com, which is a website where you can get non-copyrighted images. And next, how does sound travel? A, in circles, B, in swirls, C, in waves. For level 2, I included multiple choice options without picture supports to increase the difficulty a little bit. What part of your body do sound waves enter? Your mouth, your ears, or your eyes? And how does sound travel? In circles, in swirls, or in waves? For level 3, which is the level with the most complexity introduced, I introduced open-ended questions. What is the scientific definition of sound? What is the everyday definition of sound? How does sound travel through the air? And how can you tell that sounds travel through solids? So just to review, I went over a Nearpod presentation I created as an adaptation for a physics lesson in the New York City Department of Education Teach Hub about sound waves. And I went over 3 differentiated levels of assessment that I created using Google Forms. Thank you for watching.